Today's lesson will not be about PHP, even though we are in the PHP series. This lesson is going to be about MySQL database, which is a relational database that uses SQL to perform queries. We will only cover the basics of MySQL to kind of prepare you for the app that we'll be building and get you started with MySQL. Database is an important part of web applications that are built with PHP, and not just PHP. When you build websites or web applications, you don't just use PHP, right? PHP is just another building block, just like HTML, CSS, and JavaScript. When you put those together, you can craft pretty awesome applications. Though most of those apps will require data to be stored and persisted somewhere. While there are a lot of headless services available, in most apps you will still need some sort of database. It could be a NoSQL, it could be MongoDB, it could be SQLite, MySQL, and so on. To get started, we first need to install MySQL. I'm using Docker, so I will need to add MySQL container to my Docker Compose YML file. If you're using something like XAMPP, then you should already have MySQL installed, so you can skip this step. But if you've been following this series, then you should be using Docker that we've set up in the beginning of this second section of the course. So I'm going to paste in the container for the database, and I'll go over line by line what it does. First, we're setting the container name to programwithgeo-db. Then we're using the MySQL 8.0 image from Docker Hub. Then we're mapping to a local volume, which will store the database data and information in this location. This way, when we start up the container or we destroy the container and start it up again, it does not delete our databases and tables and so on. Now, this directory does not yet exist on my local, so if I open it here within my Docker directory, I don't have that storage MySQL directory, but it will be created when I run the Docker Compose app command. Then we're setting the root password here to be root, which is, I know, very secure. And then we're mapping the port 3306 to 3306. So our MySQL container will run on the port 3306 on localhost. So we'll be able to connect to it using either command line or one of the database management softwares like MySQL Workbench, or even web-based solutions like PHP for example. So let's run Docker Compose up here, and we're going to add the build option here so that it rebuilds the images. And I'm going to fast forward this because it's going to pull in the MySQL 8.0 and install it. Alright, looks like the container has been created. Let's run docker ps, and we see that MySQL container is running. Let's actually connect to this container so that we can test the connection to MySQL. I'm going to run docker exec-it program with geo-db with bash, and then we can run the MySQL command to connect to the MySQL. So we're going to do MySQL-u root-p, and we'll enter the password for the root password that we set right here, which is root. And we're connected to MySQL. Now, we connected with the root user, but we could also create separate users and set permissions and so on, and then connect with those users. But we're going to stick with the root for now. Then within our MySQL, we can run commands. We can run a command to list all the databases. We can use show databases statement for that. And just like in PHP, we need to use semicolons in MySQL as well. We hit enter, and it gives us the list of databases. And we haven't created any databases yet. These are kind of like internal databases. For example, the information schema here is like a database of databases. It contains the metadata or information of all other databases like database names, table names, column types, and so on. Let's actually create our own database so that we could work with it. We can use create database statement for that, followed by the database name. I'm going to call this MyDB. And we get query OK response back. So if we run the show databases again, we see that our database is now in the list. Now we could continue to manage the database using the command line, but we could also make things easier and use database management solutions and tools that exist currently. For example, we could use MySQL Workbench, which is what I'm going to be using. Or if you're working with XAMPP, you should already have something called PHP installed, so you could use that instead. Or you could use any other software that you wish, like Table Plus or Navicat and so on. So I'm going to exit from here, and I'm going to open MySQL Workbench, and we need to create a connection to our local host. So we need to click that plus icon here, and we'll type in the connection name localhost, and the hostname can remain 127.0.0.1. The username is root. Let's test the connection. It's asking us for the password. We'll enter root, hit OK, and seems like the connection is successful. We hit OK again, and we have that connection. Now we can click on it, and we're connected to localhost. As you can see on the left side, we see all these databases. We see the MyDB, information schema, and so on. Now, if you're installing MySQL Workbench and you don't see information schema and other metadata databases, that is fine. I just have this enabled through the settings of MySQL Workbench. It is usually disabled by default, and you might only see your own databases and maybe this database here. If you want to enable information schema and other databases here to show up, you could simply go to Edit, Preferences, SQL Editor, and check this Show Metadata and Internal Schemas checkbox. I have it checked, so if I uncheck this, press OK, and after hitting the refresh icon here, we see that those databases are now hidden from the sidebar. Now let's create our first table. Tables are what actually store the data. You can have a table to store users, for example, a table to store invoices, addresses, and so on. You can even have tables that relate or reference to other tables. So you can think of tables as kind of like Excel spreadsheets, for example. It has a name, columns, rows, cells, and so on. Let's create users table. We need to first select the database to which we want to create the tables and run queries for. We can do that by using the use statement followed by the database name. So in our case, that would be use MyDB. You could also prepend the database name before the table name, which will execute that query for that database, but I prefer to set the database using the use statement so I don't have to specify and prepend it in my statements. Now for the create table part, I'm going to paste in the snippet of code that creates the table and explain what each part does. We create tables using the create table statement followed by the table name. And within the parentheses, we put the column definitions. Now each user can have a unique identifier, right? That is what the first column is. This is the name of the column, which is the ID, followed by the data type of the column, which is integer in this case, and then followed by some of the options that we can specify for the columns. For example, in this case, we're setting this integer to be unsigned, which means that it can only store positive numbers and it's not going to store negative numbers. Unsigned allows you to store larger numbers. So in general, if you don't think that you'll ever need a negative number, you should keep your numbers unsigned. Then we have this primary key here, which simply indicates that this column is the unique identifier of the record or the row. Auto increment will simply automatically generate and increment the value whenever a new record or row is inserted into the table. Next column is the email column, which has the data type of varchar with a maximum length of 255 characters. And this can be larger, of course, it's just I'm setting it to be 255. Then we're setting this column to be not null, indicating that whenever a record is being inserted into the table, a value must be provided for the column unless a default value is set. And notice that we also have this unique keyword here. So let's see what this means. The unique keyword simply marks either a single field or a combination of fields as a unique identifier, indicating that the data stored in these columns will be unique. I mentioned multiple columns, but here we're marking email as a single column as being unique, which simply means that we cannot have more than one user with the same email address, which makes sense, right? However, you could also define multiple columns as unique, and you would do that towards the end of the statement, similar to how we're defining this index here. And we'll talk about that in a minute. Now, you might be asking, why do we need the unique index here? Why can't we simply make email be the primary key? And the answer to that is, sure, we could make email be the primary key, and it would be fine if we just had the users table and a few other tables that don't relate to the users table. But as the database grows and more tables are added, especially the ones that reference and relate to the users table using foreign keys, which we'll talk about in a bit, we would need to reference a column, and referencing email, which is a varchar in this case, would be less performant than referencing an integer, for example. Also, we would essentially be storing users' email address in multiple tables in a relational database, which is also not ideal. So it is very common to have the auto-incremented ID as primary keys on most tables. The next column we have is the full name, which also has the varchar as the data type. It's also set to not null. Then we have isActive column, which is kind of like a flag, either 0 or 1. And the data type is set to Boolean, but MySQL doesn't really have a native Boolean data type. So what this simply does behind the scenes is that it transforms into tiny int 1. So this is kind of like an alias to that. We're also setting the default value here as 0 while also indicating that it's not null. So if we don't provide a value for isActive, it will by default be set to 0. And finally, the last column we have is the created at column, which has the type of date time. And we could store this as a timestamp type instead of date time if the column is simply tracking the change or the creation times of the records in the table. There are some differences between the two, but we'll just use date time for now. And in the last line here, we're creating an index, and indexes can make queries run faster. And here we're explicitly creating a regular index on isActive column. I would suggest that before adding indexes to your tables, think about what kind of queries you will be executing, because adding indexes comes at a cost also, and your queries might not even use the indexes if it's not set up properly. I'm not going to go into a lot of detail on that, but if that's something you're interested, let me know in the comments and I might make a separate series on it at some point. So this is where we could also set the unique index. So instead of setting unique here, we could remove this and add comma here and put unique key and set email, which would be the name of the index, and you could name it to whatever you want, and in the parentheses you would specify the list of columns. In this case we only have a single column, but we could comma separate this and put multiple columns here, and same applies to the regular index here. So now let's create this table. I'm going to hit this icon and we see that the table was created successfully. If we hit this refresh icon here, we see the users table on the sidebar. We can use the describe statement followed by the table name to get the information about the table. So we're going to run this and we see that we have the ID, which is set to unsigned integer. It is set to not null. The key is set to primary, and this column is set to auto increment. Then we have the email, which has a unique key, and so on. If you wanted to add new columns or modify an existing column or drop columns from the table, you could use alter table statement for that. So you would do alter table users and then either do add column followed by the column definition. So we would do foo varchar 150, and this would add a new column foo. And we could either put a semicolon here and run it to add a single column, or we could simply add a comma and add multiple columns or drop columns. So we could do drop column isActive, for example, or we could simply do modify followed by the column definition. So we would do something like full name and change it to varchar 150. Let's run this code, and sure enough, it executed successfully. Now we can run the describe users statement again, and sure enough, we see that isActive is gone and we have a new column called foo. And also the full name column was modified to varchar 150. So I'm going to revert that back and I'm going to recreate this table, but before recreating it, we can drop the table using drop table statement and then create the users table again. So let's run that. Let's run describe users again, and sure enough, we're back to normal. Now, as I mentioned before, we are not covering everything about MySQL. There are a ton of other things to know about, like normalization, table views, functions, other data types, and so on, but that is beyond the scope of this lesson and series. You don't need to be an expert in database administration to build an app. You will get familiar and learn things as you build stuff. So don't worry about it too much right now. Alright, so now that we have the table, let's actually insert some data in it. So we can use insert into statement for that. So we'll do insert into followed by the table name, which is users, followed by the parentheses, and within the parentheses we specify the columns that we're inserting the data to. Now we don't need to specify the column for the auto increment because that is automatically generated for us. So we can do email full name isActive and create it at. Then after specifying the columns in the parentheses, we can specify values that we want to insert. And as you notice, this is not case sensitive. So these keywords you can do all uppercase or lowercase, it does not matter. Then within the values, we have the parentheses here, and within the parentheses, we specify the values that we want to insert. So we can do johndoe.com as the email. Full name would be John Doe, isActive1, and created at, we can use the function now to get the current date and time. Now if we run this, this is going to create a single row, or we could simply create multiple rows by adding comma here and putting another parenthesis. So we can create another user here, Jane Doe, and we'll mark this active as well and set it to current time and run this code, and sure enough, 2 rows were inserted. Now we can select the data using the select statement. So we can do select star from users and run the code, and sure enough, we get this table containing 2 rows, John and Jane Doe. As you noticed, we're selecting all columns here. That is what this star indicates, but we could narrow this down and only select the columns that we actually need. So let's say we only needed ID and email. We could simply specify ID comma email, run the code, and we only get ID and email. We could also add filters using the where clause, so we could do where ID equals 2, for example, and this would return the user with the ID 2, or we could do where is active equals to 0, and this will return nothing because we don't have any users that are inactive. We could also sort the results using order by clause, so we could add order by here followed by the column, so we could order by created at and either ascending or descending. We could group the data by columns, we can join other tables, we can select data from other tables, we can run functions and so on. Now if we wanted to run a search where email contains some text, for example, we could use the like keyword with wildcards. So we could do something like where email like, and let's say we'll do Doe, and these wildcards indicate give me all the rows where email contains this text here. So if I run this code, we get both because both of the users contain this text. If we change this to something like John and run the code, we only get one. If you only wanted to match the beginning of the string, then you could remove this from the beginning, and this would only return the records where the string begins with John and ends with anything else. So it would only match the beginning. So if we ran this, it would again return John. If we ran it with the J, it would return both because both of them begin with J. But if we ran it with JA, then it would return Jane. On the other hand, if you wanted to match the end of the string, then you would add the wildcard here and remove it from the end. And now it wouldn't matter what it matches in the beginning, it would only match the end of it. So in this case, if we match to .com, for example, and run it, both of them are returned because both of them end with .com. Also, you could negate this and simply add the not here, and this would return nothing, of course. But if we did something like not like John, it would return Jane. All right, let's move on. So we covered insert, we covered select, we covered create table, drop table, modify columns, and so on. Now let's cover how we can actually update the records. So let's say that we wanted to change the email of the Jane Doe. We could use the update statement for that. So we could do update users set email equals to jane@gmail.com, and be very careful with this because if you don't specify the where clause, what this is going to do is that this will update all the records in the users table. Now if I run this code, we're going to get this error about the safe mode because it thinks that we made a mistake here, that we're not specifying a where clause. So if we wanted to override that and still execute this query, we would need to either disable the safe mode, add the where clause, or add the limit clause. We haven't talked about the limit, but limit clause can be used to limit the number of rows to be returned when doing the select query, or number of rows to update or delete. So in this case, we could add the limit 5 to only update 5 rows, but because our table only contains 2 rows, both of them would get updated because we're not using the where clause. And if I hit run here, we're getting another error now about the duplicate entry. And this makes sense because we're updating all the users, in this case only 5, but in reality we're technically updating all the users' emails to jane@gmail.com, and we have this email column set to be unique, and therefore it's giving us this error. But if this was something like is active, for example, and we wanted to deactivate a specific user and we did not specify the where clause and we ran the code, it would deactivate all the users. In this case, I'm specifying limit simply to avoid that safe mode error, and because we only have 2 users, you can see that it updated both users. If I run the select all from users now, we see that both users are inactive even though we only meant to deactivate Jane's user. So that is why it's important to specify the where clause. So now we need to enable John's user, so we would do update users set is active equals to 1, where ID equals 1. If we run this and then run the select again, we see that only John's user was activated. We could delete records using the delete statement, so we could do delete from users, and again, if you don't specify the where clause, it's going to delete your entire table, but in the safe mode it's going to prevent you from doing that unless you specify a where clause or a limit. But in this case, if I did limit 5, it would again delete both users, which is not ideal. So be careful with this and make sure that you always specify the where clause. So we'll do where ID equals 2, and this will delete Jane Doe's user. So if I run this and then run the select from users again, we see that the Jane's user is now gone. Note that deleting rows does not reset the auto increment ID. For example, if we delete all rows and then insert a new row, the ID will still continue to increment where it left off. If you wanted to reset the auto increment back to 1 when deleting everything, you would need to use a truncate table statement. Alright, let's talk about the foreign keys and relationships between tables. Let's create a second table called invoices. So we're going to do create table invoices, and again the first column will be ID, which will be unsigned integer, and this will be the primary key and auto increment. Then we can have an amount column to store the invoice amount, which would be a monetary value. There are multiple ways you could store monetary values, and it depends on what exactly it is that you would be storing and how it would be used. I personally would not store monetary values as float data types due to possible rounding errors. The data type that I will be using is called decimal, which is a fixed point type, meaning that we get to set the fixed size. So decimal 10,4 means that at maximum we can have 10 digits, but 4 out of those 10 digits are the digits to the right side of the decimal point. Now, of course, you could store larger numbers. For invoices, we probably wouldn't want to limit ourselves with the 6th digit before the decimal point, but for this example, it's good enough. And for the third column, I'm simply going to use user ID, which will be the reference to the users table. And the type of this column must match the type of the original ID column in the users table. And as you remember, in the users table, we set the ID to be unsigned integer, so we can do the same thing here. And now we can add the foreign key this way, and in the parentheses you set the column that is the foreign key. So in this case, that is user ID, that is the foreign key, which references the users table, and it references the ID column on the users table. Then after this, we could add some additional options, whether we want to cascade if the reference record gets deleted or updated, and so on. For example, if we had a user that had 10 invoices and then this user was deleted from the users table, we would be left with 10 orphan invoices, right? Invoices, of course, is not a good example for this, because even if we delete users, we wouldn't want to delete invoices. So in this case, we would not want to cascade. Instead, we would want to make user ID nullable and set it to null. So we can actually specify that in the options. We can say that on delete, we want to set it to null, but on update, we want to cascade. We can put these on its own lines so it's easier to read, and let's execute this code. Now, if we set the cascade here instead of the set null on delete as well, whenever a user would be deleted, all the invoices that are associated with that user would also get deleted. And that might not always be ideal, because sometimes you don't want to delete those essential records like invoices. In this case, we wouldn't want to get rid of invoices if the user for whatever reason is deleted. But in a lot of cases, to avoid orphan rows, it would set cascade for on delete as well. Alright, let's actually insert a couple of invoices here. So I'm going to insert into invoices, and we're going to specify the amount and user ID, and we'll do 25 for the user 1, 115.95 for the user 1 as well, 10,500 for the user 1 as well, and so on. 3 records should be enough for now, so let's run that and let's confirm that we have that. So we'll do select from invoices, and we have the 3 rows and they reference to the user. Now let's say that we wanted to get the ID of the invoice, the amount of the invoice, and the user's full name or user email. So let's say that we wanted to get user's full name, so we need to get full name. Now if I run this is not going to work, of course, because full name does not exist on invoices. This is where joins can help. We can join other tables to get additional information from those tables. There are different kind of joins, but in MySQL you will probably mostly use inner and left joins, and maybe right join as well. Here is a simple diagram that shows the difference between the inner, left, and right joins. Inner join returns rows where there is a match in both of the tables, so in this case invoices and users, for example. Left join would return records from the left table even when there are no matches in the right table, while right join would return rows from the right table even when there are no matches in the left table. So let's use inner join for now. So we'll do inner join followed by the table name, which is users in this case, and then we're joining users with invoices table on the user ID column, right? So we'll do on ID equals user ID. If I run this code, we're going to get this error that column ID in field list is ambiguous. What this means is that it simply does not know which ID column we're referring to. Both invoices and users table have the column called ID, and therefore it doesn't know if we're referring to the invoices ID or users ID. And same applies here, it doesn't know where we're joining it, whether we're joining it on the users ID or invoices ID. So one way we could fix this is by prefixing the column with the table name. So we could do users.id here, and in this case we could do invoices.id because we want to select the invoice ID and not the user's ID. And because the ID is the only column that is conflicting, we don't need to prefix the table names on other columns because we don't have the amount on the users table and we don't have the full name on the invoices table. So we don't need to prefix those, and we only have the user ID within the invoices, and we don't need to prefix that either. So if I run this code, we see that we get all 3 invoices for this user. You could of course set the conditions here, something like where amount is less than 100, and this would return 1 row. You could also combine multiple conditions using logical operators like AND or XOR, for example. There is of course a lot more to know about MySQL, but we can cover it all in this series. There are plenty of built-in functions in MySQL that you could use, like count, max, min, concat, and so on, which you will learn as the needs arise. If you want to learn more about MySQL, I suggest you to take a crash course on it or read the documentation. We'll also cover more MySQL things as we go along with the series and work on a project, but this should be good enough to get you started and prepared. In the next lesson, we'll see how we can connect MySQL with the PHP and run some queries using PDO and prepared statements. If you like my tutorials, please give my videos thumbs up, share, subscribe, and comment, and I'll see you next time.